Hello and welcome to our first challenge. In this challenge, assume that you are a data scientist or a data mining specialist. Let's say you work for an auto insurance company or a data-related consultation company. Your task is to detect if a customer's car was in a crash before or not. Think of it. The success of this task for sure will save the company a huge amount of money. Why? Because they can avoid providing high-rated insurance for cars with accidents history, whether that's mentioned by the customer or not. This is a great exercise for experiencing how data science works. By completing this task, you will be able to perform basic data exploration and preprocessing. You'll be able to apply classification techniques, and you'll be also able to evaluate the performance of the classification models. But before we start exploring our dataset, please do not forget to hit the subscribe button below so you can stay updated. Alright, this is our dataset and we're going to explore it now. So knowing your data as a data scientist is very important because there is no way you treat the data as black box. So a data scientist has to understand the data in and out in order to do successful analysis. So this is an example of a dataset for the same problem we just mentioned. So this data is related to, again, to a car and a customer's information and whether this car was in accident or not. So look at it. There are a few things we have to note here before we start the analysis. And the first is, the rows here, we call them instance, or in some cases they call them examples. So the instance is independent examples of the concept. There is another important thing here we have to note, which is the attributes or the descriptive features, or simply they call them features. The features measuring the aspect of the instance. For example, in our first case here, we have an idea of a person, his age, right? His income. In this case, how much is the value of his home or her home, married or not, whether it's a male or female, the profession, the occupation, the travel time per day, the average travel time, the car use, whether it's private or commercial, the car value, how much it is, type, minivan or a van or a sport car, whether there is an old claim and the amount of the old claim, how old is the car, and then we have important column here which represent the class or the category. This is the kind of thing that can be learned. So in this case, 1 indicating that the car was actually in a crash before, given this attribute. So 0 if it's not. So for example, here, this case was in accident before. Now, the purpose here is to use the data we have in order to develop a model. In this case, since we have a class, we can develop a classification model. Of course, we're going to learn the details of doing this. But the purpose here is to create a classification model. Why? Because I can use this model to help me detect the class of future examples or instances. So once you build a learning system here, when a new customer can come and apply, then straight away you can know this particular case was in accident before or not. This is actually taking us to a very important concept in machine learning. We call it supervised learning and unsupervised learning. And this is a case of supervised learning. Why? Because we have a class or a label. So, since we have a label, then even when we develop a model, we start to find out some patterns could be related to the outcome. And also, this class will help us in order to determine or calculate the accuracy of the model. Meaning, if I have, let's say, for example, this part as a testing examples, I already know the label. I just want to know whether my model will detect it correctly or not. And obviously, in this case, I can calculate how accurate my model is. Well, after we understood the data very well, the next step is to perform our pre-processing. And the purpose of the pre-processing is to clean the data, make it ready for the mining step, or to be ready for extracting more valuable patterns from the data. We have seen a lot of work. People just pick pre-processing techniques and run them in all dataset regardless. And this is not the right thing to do. By understanding your data, you know what kind of pre-processing is needed for this data. For example, if you have few attributes, it's not necessary sometimes to perform, for example, attribute selection. If you have big size of the data with several attributes and you would like to reduce the computational complexity, that is possible. Let's look at our data. And let's pause for a second here. Can you see something in the data need to be at least corrected before we go to the next step? All right, let's have a look. All right, how about missing values? I'm sure each one of you noticed that. We have some missing entries here. For example, in this case, here and here. Missing entries or missing values is very important to deal with to improve the accuracy of the training model in most of the cases. All right, what else can you see in this dataset? There are some redundancy. And if you see here, the first and second examples or instance are actually identical. So, in terms of the accuracy of the model, the redundancy won't help the model to be more accurate. But it's rather you're adding computational complexity to your training model. Deleting redundancy is very important. All right, what else? How about some entries which are not correct or do not make any sense? For example, if you look here, the car you use, usually we have it as commercial or private. But here, private is spelled wrongly. And for any learning system, we'll understand this is another variable within the same column here. So the column here will have three variables, private or private with a wrong spelling or commercial. And of course, that's not what we want. This entry here should be private, the same. Another thing here, under the gender column, most of the column, as you can see, is either male or female, M or F. Somebody put female here, again will be considered as a third variable, which is not correct in this case. So, this is need to be corrected as well. here under age, it seems like the 0 is just added, as a typo. There's no person his age will be 540 years old, right? So the 0 has to be removed. Maybe. But we understand there is a mistake, clear mistake here in terms of age. Let's see what else. There are some useless attributes, and as I mentioned, if the data is small like this, then removing attributes might not be a good idea because it might not reduce much in terms of complexity, unless the column is adding noise rather than information. So the attributes which are useless can be removed to improve the computational complexity as well. So can you figure out what column that could be removed? I know you get it right. The first ID here, of course, after we remove our redundancy, then this is a unique value for each and every instance. And unique value will not help our model. And that's why it will not add any value to the training model. So, all right, we understand this is, in this case, each value is different from the other, right? It's unique values. But if you look at this column, what's the problem with this column? Which is the status, whether the person is married or not. For this particular data set, all the cases are just not married. So in this case, I don't have to keep this column because it doesn't add any value. In fact, it may add noise. Why? Because for a case such as this and a case just right above it here, they are supposed to be different. Why? Because the class is different. So the 0 has to be in a 0 class and 1 in 1 class. But the more you have attributes that they don't distinguish between the two and treat everything as the same, that in fact will affect the classification accuracy. And it's better if you remove a column with only one value. All right, anything else? Of course, there are more pre-processing techniques that could be helpful to be applied here, such as, for example, this data is clearly unbalanced. By unbalanced, we mean one class is more dominant than the other class. And this is a typical problem in data science or in machine learning. So, in class 1, we have only 3 instances, but we have 7 in class 0. So 70% of the instance actually belong to class 0. And this may affect the classification ability of your model as well. Of course, we need to find a way. If we can balance these classes, that would be excellent for our learning process. We're going to deal with this in the future, and we can see how we can handle it when we do our practical part based on this lecture. There are other pre-processing techniques which could be very helpful when we normalize the data. Because when we normalize the data or scaling the data, we're making the data points generalized, close to each other, make the learning even more efficient. This is another pre-processing technique can be applied here, especially when you have things like the one we mentioned here. All right? So, now we understood what kind of pre-processing work we do in our data. When we perform this pre-processing, then our data will look better and then we'll be ready for the learning step. But if you look here at, for example, the $sign, do you think we should remove them? In some cases, it depends on what kind of learning system you use. But since you define what the column all about, you don't have to keep it. For example, if you are using Excel sheet, you are reading from Excel sheet or CSV file, then the dollar sign is understandable to affect the value. But if you remove it, since you know we are talking about car value here or house value or income, then it won't make any difference. It's better if you keep it away. Alright, now, the pre-processing, let's assume that is done. Of course, if you look at the data, we did not really make that changes. But let's assume that we have the data set ready now. So our next step in the process is actually to input your data set to a classification model in order to start learning from it. But somebody may ask a question. The idea here is we understand that from this data set, which is the training data set here, you are going to create or apply a classification technique. Why? Because if I have a new case, the new case can be compared to the model, then the model will advise this class will be 0 or 1. That's what we are looking for. All right. That's perfect. But let's understand when we say model, what's the model look like? If we look inside this model, what it is. There are many classifiers. And how the classification work in this case. So let's look at two dimensions here. In this case, let's assume only two, we're picking only two dimensions or two columns from the data, the income and the car value, for example. The income and the car value. So if you take these two, you can plot them in X and Y, Z, in X and Y axis, right? All right. So then we find that in this case, let's say this is just a hypothetical representation of the model. Then you may have, this is the first class and this is the second class. The class, let's say, of zeros and 1. Of course, this diagram doesn't really correspond to this data set because we have only 3 in one class and 7 in the other class. But here to illustrate how the model works. So now, if we plot both of them, then we have our points the way it is. Then in this case, we can easily separate between the two classes by having here linear separation. In advanced topic later on, we can look at techniques like support vector machine, for example, classifier, which try to learn to maximize the margin between the two classes here. We're going to talk about this in the future. But as I mentioned, this kind of lecture is meant for somebody starting with zero knowledge, and then we're going to grow together until we go to advanced level. So if I have two dimensions and I plot this from my training data, now I have the new case, which is the case 3577609. Let's say this. When I take the same X and Y axis, which is the income and the car value, this is the income here and the car value, then let's say I found the point light here. In this case, I'll know straight away this is going to belong to class the circle red, whether it's a 0 or 1 or whatever. So that means here this kind of new data point is belong to this class, not this class. If I have a new case fallen, let's say here, this will belong to this class, not that class. That's the basic idea. Of course, in this case, we have more than two dimensions, and that's the beauty of going from two dimensions to multi-dimensional. Because the separation cannot be, just linear. Or sometimes you may look at a class and you cannot have a linear separation. But if you have a 3 dimensions, maybe you can find that separation between one class and others. So the higher the dimensions are, sometimes will give us more, better ways of classifying data. Okay, now let's have another example. It could be a neural network. These are your input here. Let's assume here we have only 4 for illustration purposes. Then you have your hidden layers. We're going to talk about this in the future. And this is the class. So basically, you have weights will be assigned to each and every line here. And then we're going to learn whether this will contribute more to 1 or 0. We're going to talk in details on this. We're not going to, introduce the topic right now. Or it could be a decision tree. So if you look into this, this is another representation of a model. I'm sure most of you heard of decision tree. So look at this example here. If we take occupation as a root here, then it has several variables. But you notice that whenever we have the variable manager, we always have a decision as class 1. And this here, we call them nodes. These are links, and these are the leaf node, which is the class. So if you look at our data here, see, whenever the occupation is manager, the class is always 1. And this is a kind of a patterns which is very important for us to make decisions. So if somebody comes to you, and for example, in this case, a novel case, this is a manager, for sure this class will be 1. Even if I don't look even in the rest of the attributes. That will give me a huge hint on a manager. Usually, yes, it doesn't mean managers making accidents all the time, but according to my training data, whenever the occupation is manager, is the case, is always leads to accident or previous car crash. So, but when we look at blue collars, for example, then we cannot see that. You see, blue collars could be 1, blue collars could be 0. So we cannot say when the occupation is blue collars, that means which police and military. It doesn't mean straight away the person was in accident or not. This is not an indication here. In case of manager, 100% of our cases leads to previous accidents. Blue collar, not necessary. But if you look at blue collars, and then you go on car types, whenever the car is a van, they always have previous accidents. Not like other type of cars. So this kind of patterns will help me to, straight away jump into decision, right? And the model is just a collection of this kind of evidence and patterns for better classification. And the model could also be just represented as rules, as you can see here. If occupation is manager, the claim flag is always 1, right? Or it could be something like this. If occupation is manager and the car use is commercial, then the claim will be, the flag will be 1, or the class will be 1 in this case. Okay? So this is how our models, this is a quick overview on how the model will work, on how it looks like from inside before we apply it. Alright, now we understood what's the model all about. So again we said, from our historical data here, we can create a model to be used for future or novel data, right? So we can make easy decision here based on the model developed from our history, from the data we have. So, but how can we evaluate our model? How can we say this is an accurate model to be used? There's many ways of doing this. The simple way is to split your data into training data and testing data set. So in this case, I can train the data, I can train the model using only my training data set, the one highlighted in red here. This is the one will be used for as input for the classifier. So what's the purpose of the testing data set? This is to address the generalization issue. The best way to do it is to test the model. And in this case, as we mentioned, we have already know the label. So when I train the data on the red samples here or instance, then when I try with the green ones, which is the testing samples here, the model will advise me on what the class will be. And based on that, I can see, is the model predicted these classes correctly or not? That's very important. Then I can use it. Let's say I got the 99% accuracy or 90% accuracy. Then we could use it to predict novel classes like the one you can see right here. So you can simply calculate the accuracy by looking on something we call it true positive, true negative, false positive, and false negative. Or the accuracy simply how many detected correctly versus the total, right? What's the true positive, true negative, false positive, and false negative? Let's see. Let's assume that you have 100 samples, and this is the actual class. So your model predicted these classes this way. You can straight away see there are some, classes not detected correctly, like the one highlighted in red. And also the one here in purple. You can see here, this is not also detected correctly because it's supposed to be negative. So here the true positive is, if it's originally positive and detected positive, this is a true positive. And if it's negative, predicted negative, this is a true negative. And that's what we are looking for, is to have more of the true positive or true negatives. But we have here a negative value which is supposed to be positive, so it's a false negative here. This is not a true negative, because if it's a true negative, it will be here. So we have here two false negatives, and we have here one false positive as well, because this is not a true positive, this is a false positive. But if you think of it, why are we looking into this? What about accuracy? Is not enough? Of course not. Why? Look at this typical case. And if I want to calculate the accuracy, what the accuracy would be here? Of course, let's even make it more like the detected classes, all of them are negative. Imagine this is all negative. So in this case, I'm getting 95% accuracy. It's very high accuracy, right? But none of the positive class is detected. And this result is deceiving here. Because in some cases, you have classes, we talk about unbalanced data, but you can have a typical example like this. Could be a rare disease, or a success in operation, or dealing with disease, or medical surgery, or anything like that. Rare cases. And it's very important for me to detect the positive class here. So by detecting nothing, just putting all negative, I'm getting 95%, and that's not accurate. In this case, I'm getting 97%, but also it does not reflect how powerful the model is, because 2 out of 5 of the positive class are detected wrongly. And that's why we can have different measures, such as recall and precision. And if you see here, recall, we're again taking the true positives, which is the true ones here, plus the true positive, divided by the true positive plus the false negative. So that means basically I'm looking at this class here for the recall. And similarly for the precision. In this case, we're taking the false positive in consideration, not just the false negative. So both of them will give me a better view on the two sides of the story. And then we can combine both, in which we call as F measure, which equal to 2 multiplied by the precision multiplied by the recall divided by precision plus the recall. In fact, I was not intended to have formulas in this initial lecture, but at least this is very understandable when you look at these formulas here. So this leads us to which we call as the confusion matrix, and this is very important concept. Remember when we say if it's positive, detected positive, we call it true positive, right? And if the actual class is positive and detected negative, this is a false negative. Negative detected negative is true negative. Negative detected positive is false positive, and so forth. So the confusion matrix is the best way to evaluate our model. But in some cases, we notice that the data is too small. Because remember, we said we can split it into training and testing. In some cases, we're going to talk about this in the future, which in the case we have training, testing, and also validation data set. And we'll learn later the validation is just to ensure that you don't fall in overfitting the data by each classifier has different parameters to set, and you don't want to adjust it to the level that you improve your training very well, and then when you test it on a testing data set, then you got horrible performance. We're going to talk about that in future lectures. Now, if we have if our data is too small and would like to do the same thing, we can try something we call it 10-fold cross-validation or k-fold cross-validation. In most of the cases, data scientists use 10-fold cross-validation. And in this case, the data we have, we can split into 10 pieces. And we can take one piece as testing and the other 9 as training. And this process is repeated. The next step will take this as testing, remaining as training, followed by this as testing, and the rest as training. This is a better way to justify that you're not in favor of taking some testing data set for your data set to look good, or for your model to be more accurate. Because each and every example sometimes fails in the testing data set and sometimes in the training data set. So we can calculate the average of this process and we can have better evaluation of our model. So, and again, a confusion matrix could be used here in order to calculate what's the accuracy, recall, precision, and F-score. Well, after we understood how the pre-processing work, how we can apply machine learning classifiers, and how we perform our classification model, the next step is to practice all that in a lab session. First of all, we're going to download the dataset. Of course, I'm going to leave a link for the dataset in the description below. I'm going to also put the small dataset we discussed because we can also explore it further using the Weka tool. The original dataset contains more than 8,000 observations or instance and 26 variables or features as we mentioned. So we're going to perform the exploration and the pre-processing. We're going to replace missing values. We're going to remove redundancy, correct some entries, remove useless attributes, all the pre-processing steps we talked about. We're going to apply classification techniques such as support vector machines, neural network, random forest, decision trees, and also a naive Bayes and k-nearest neighbor. And also, we're going to evaluate our classification model performance. We're going to see how the accuracy, precision, recall, F-score is calculated. So let's dive in the practical session.
Hello and welcome to the lab session. So here we try to practice what we have covered in our lecture. You remember this dataset. This is a sample dataset here with some of the pre-processing um, work we need to perform before we apply modeling. So the dataset here, we have it in Excel sheet, could be in a CSV file. So what you could do now is simply start your Weka. So we're gonna explore the data. So you use this application here, the Explorer. Then another window, of course, will open up, which is this window here. So what we will basically do, we're gonna open this file, the file in the desktop. In this case, you see nothing here, right? In my desktop. Why? Because here we look at Weka extension, and our file is in CSV, so you can check the CSV file, and this is our sample data here. So with a simple click, you can see the data now is in. If you recall, the data has just 10 instances and 14 attributes, right? So the first thing we do is to tell Weka which one is our target or label, because you don't see colors here. That means Weka did not recognize the class, and the reason why is you can even see your data here. This is the missing entries. This is, for example, the problems, the errors in our data. And also, you could see the duplication in the first two rows. And for example, useless columns such as this. As we mentioned, you can also remove the unique attribute here. This is because all unique and here all the same. And in both cases, they don't help the prediction or the classification. So the first thing is to tell Weka this is the class. And the problem here, because this column is in 0 and 1, it doesn't look like a class. It's a numeric value. Unless we say 0 represent, for example, no accident, and 1 represent accident or car crash. So the first thing we do here, we're still under pre-processing tab. We choose unsupervised learning, and we would like to deal with attributes, right? Then we search for changing numeric to nominal, because this is how Weka will understand it. This is actually a class. It's not just a numeric value. So, but you need to click here to mention which one you want to apply to. You can simply say the last one, or you can just write number 14 because it's the 14th, the attribute number 14. Okay, and apply. So you can see the difference now. When you click in here, then these are this is the two classes. This is the first one, which is with a 0 value. We have 7 of them. With 1 value, we have 3. Right? So let's perform some of the pre-processing we mentioned. Things like, for example, removing useless ones. So when you remove useless here, you expect at least this column to be removed, whether the person is married or not, because in all cases it's no. And maybe the index or maybe not, because sometimes considered to be or maybe it's repeated because of, if you take this step before, it's repeated here. That's why it may not be removed. When we click on this column, because we know it's useless, you could see here there is 0 unique value, and all are the same, right? So that's why there is nothing. All 10 are actually just no. Let's perform that task. Since we're removing one of the attributes, right? We're removing attribute in this case. So we'll go again to choose for a method to do this, which is if you go down here, still we're under unsupervised attributes. You can see here remove useless, right? Remove useless. So here, let's just have a note of this. We have 14 attributes and we have 10 instances. So when we apply, now we have 13. One is gone. And you can notice straight away the one we, already think like it will be gone is the one. Let's look at the data. There is no Marshall status here. It's gone. But still the ID is in there, and you can remove it manually if you wish. You can just select it and simply remove it if you know your data very well. You can always, whenever you do mistake, you can undo the step. Okay, so it's okay. We can remove this. The second is also to remove duplicates. These are instances we want to deal with here. So you can go to choose again. In this case, it's not attribute, instance. So remove duplicates here. When we apply, again, here we have 10 instances, and when we apply, now it's 9. And you can know why, because the first two are actually identical. Now one of them is gone, remaining one. Right? So for the correction of errors, you can do that actually manually. You can do it automatically. But since you understand your data very well, especially when you look at your Excel sheet here, this is the first thing you do. You examine your data before you do any, pre-processing. So age, when you scan it, any 3 numbers, there is something wrong, right? You know it's straight. Even if you have millions of the record, still you can see whatever above 100, let me see it. Okay. Another thing is when you filter, let's filter these columns. We expect this to find it unique values. Age, you can see straight away the range, for example, from 34. This is the one here, 540. This is the one could be fixed. Probably there is no 0 in here. Another thing is when you look at gender, then you see female, again, female is spelled out, and male. You can simply do the correction right away here. Similarly for the misspelled private in here. You can also do it in Weka straight. You can go for edit. This is instead of 540. For example, this one is actually just 54. And we have another thing, which is, for example, female here. The female is actually female, F. All right. And private here, for example, is actually private. So now the data is clean, okay, and the data is corrected. So the next step is to do the mining. This is the pre-processing step we talked about. You can, perform them right away because you know what you're doing. So if you go to classify here, this is where we do the classification. So here we just do training. We're gonna do, if you have, let's say your data split it into training and testing data set. In this case, you can have a training data set, and then you can supply the testing data set. Or simply perform cross-validation. Remember when we said 10-fold cross-validation or 5-fold or whatever, that means splitting the data, in this case, into 10 pieces. One piece will be testing and the rest will be training, and then the next piece will be testing and the others will be training, and in this case the process will be repeated 10 times before we can get the final accuracy. You can simply split the data the way you like it, let's say 66% as a default value here, but you can have it as 70, 80, whatever you depends on your problem. But we need to let's just keep it as a training set, but we need to choose the learning method. Here you can simply go and find all the learning and classifiers here. For example, you go for naive Bayes. You can go for something like this is actually deep learning, but you can go for something like a neural network. You can go for something like implementation of support vector machine, for example. This is another neural network implementation. You can go here for IBK, which is nearest neighbor. You can go for trees, for example. You can see here random forest, one of the popular classifier and decision tree implementation. Let's choose decision tree for now. And now when you start the process, then everything is done here, right? So straight away we know that we have 8 classified correctly in this case, because we're using the whole data as training set. 1 is not, so that's why our accuracy is about 88.9%. This is here, you could see your confusion matrix, the one we mentioned in the lecture. So if A classified A, then there is 6, right? Which is in this case correct. This is the zero. Remember 0 values, and we have also the ones value, right? The one we have only 3 here. 2 classified okay, but we have a problem with 1. This is our second class predicted correctly. This is the first class. Nothing from the class 0 is actually detected wrongly. All of them are correct. But let's assume this is our positive class. Then we have 1 here which is not right? So this is the one we missed here. That's why we got not 100% classification. But if you try different classifier, let's try for instance random forest, you may find different results. In this case, everything is detected correctly, including things like precision and recall, the one we mentioned in the lecture, and the F score for the 2 classes, for the 0 class and for the 1 class. All right. So also, of course, you can split the data, but the only thing, this is too small data to be split. Let's say if you split it as 70%, you might not get any. It's still a small data set, and we have only 3 samples from the accident class. So in this case, it's very difficult to detect it, and you could see here the detection is not really good. So we cannot do cross validation because simply you cannot split that data into 10 fold, but we're gonna try that with a little bit more data set. So another thing in the pre-processing here, we can remember we did also replacing missing values. So here we could see we have a few missing entries and we would like to replace them. This is the basic. Of course, there are many methods, but the basic method here is to find an average. But not only for numerical value, but for nominal entries. For example, here, this private, we don't know, it was missing. But you see here the majority are actually private, right? So expect the private to be restored correctly. So you see here, we don't know it. So we go again here, and if you scroll down under attributes again, then you find here replace missing values, and you can simply apply it. And you can see right away here everything is replaced. Private is replaced back. I think here the average is calculated from the previous when we saw the data set previously. So the data is clean now, is complete, and it could be processed correctly. All right, this is how we deal with the pre-processing, how we can actually see the confusion matrix and evaluating our model. And the only thing left for us is to perform, of course, something like cross-validation and percentage splitting. Let's do this by looking at another file here, which we call it let's car2. So in this case, I just took sample from the original dataset. Let's look at the original dataset. This is the original dataset, and I'm gonna, as I mentioned, I will share it with you. But here you could see it in the, of course, the description below. But These are the attributes. They are more than the one we mentioned in the class. We selected some, but here they're all of them. In case we have 26 plus the class here. But this is too big data. We have almost let's see, 10,302 uh, and two an instance here. This is the data is too big, right? I just put for you the one in yellow here, the description of each and every um, uh, label here. You can see, for example, this is just an ID, but when we say, for example, something like Y or J, we mean years in job, for example. So all these attributes are important attributes, and this is how the data looks like. For this exercise, I just took some of this data for the interest of the running time and the complexity. Let's open the file with a little bit smaller data set. So we could see here the data set has 500 instance and 27 attributes. We took all the attributes as they are, but we reduced the number of samples. So these are the attributes and the description. You find them in the slides, as I mentioned. In the Excel sheet. So we'll do the same thing. First of all, let's notify Weka. This is the class again. And remember the steps here. We're gonna go for unsupervised and attributes, and you go here from numerical to nominal. Which one? We say the last one, or simply you can say 27, right? As we mentioned before. So when we apply it, then number 27 become the class here, and you can see here we have 300. In purpose, I make it not balanced data. 300 for class 1 and 200 for class 0. This is no accident. This is accident, right? So of course you can perform the same thing we did before, replacing missing entries, things like remove useless and all that kind. You can perform all this process, and then you can simply classify using, let's say, let's take decision tree, which is quick. If you take 10-fold close validation, then in this case we got only 60%, because nothing detected here. There are so many pre-processing and evaluation of attributes to be done, right? But if you try something like random forest, it might take some time, but it will give us better results. Why? Because random forest it takes a combination of trees together, and you could see here we got 97% detected correctly. We have only 13 and 1 misclassified. Here is 14. Those are the false positive and false negative in this case, right? So, but there another thing which could speed up the process and could also make the classifier work better. If you select attributes, of course we can do it also from the pre-processing. You go here, since we're dealing with attributes, but we have to use supervised in this case, because we're going to use the label to tell us which one contributing to the right label, it could be kept or removed. Attributes, and you can see here attribute selection. So let's select attribute using this method. There are several methods to do this as well, because if you look into this, then there are many methods. Even when you click in here, then you find many methods. I could choose from a number of methods here. Okay, so when we apply it, we find, for example, there are only 2 attributes which are very good attributes that could show straight away how good these attributes are, and the rest maybe the contribution could be little, or they may even add noise in this case. So when we try again here using, remember decision tree detected nothing in that case. Let's try it again. It's still nothing, although the same, we're using only two attributes here. Let's check again with random forest, then cross validation, and this time we're getting 100%, although we're using only 2 attributes. because they're just informative. Another way is can always do undo and everything is back. You can go for select attributes, and you can use whatever method to evaluate your attributes, which one is makes sense and which one is not. And this will also give you indication of which reason you can take to know the car had accident or not. So if we take something like information gain, we're gonna discuss it in some of our future lecture. In this case, the class could be this, of course, the same one. And if we just do this, then we could say straight away, claim amount is very important attribute here. For sure, for some reason, the birth, which is the age, and I'm not sure why this is an important here. Something like also the type of car, but you could see here there are things which doesn't, for example, here in the job, it has no correlation with accident or not, or whether the car is old or not. The ID you can expect that doesn't contribute much. Traveling time also doesn't contribute much. The rest are actually contributing little. Those are the two or three attributes that are actually turn out to be important according to this method. You may use, of course, different method, and you may find different, for example, different attributes. For example, here you find only two. In this case, the one we just used. So this is the way you perform selecting attribute and look at which one is important and which one is not. Also, you can go here when we use random forest. If you click on the bar here, then you can see all the parameters related to random forest, and you can adjust that. But one of the things we are interested to do here is to look at how important the attribute is. By default, it's false because of computational complexity, but we can make it true, and then we can run again. And in this case, not only we'll get the result, but we're gonna get also, see here, which attribute are actually contributing the most and which one is not. In this case, of course, we're using all the attributes. You see income is the first, for some reason, the first attribute, random forest selected. I don't know, people having money, is it, or higher salary or low salary, is it indication for having a car crash or not? Kids usually driving, maybe when you drive kids, you be more careful. So turn out to be here important. The claim amount, and I have a suspicion also the claim amount has a leak to the class. Why? Because if you claim anything before, obviously that means you involve in accident. Although it's not correlated directly in the dataset, but I think it gives some hint. Another thing, how much is the home value and things like this. All right, so that's about it for the first lab, and at least we explore the basic pre-processing. We applied different techniques here. Also, we learned how to look at the confusion matrix and look at the cross-validation results. And basically, you can also here, as we mentioned, you can split the data into, for example, training and testing. Let's use different technique. In this case, let's go for nearest neighbor, for example, unapplied. For some reason, this is the accuracy is 75. We split the data into 70% for training and 30% for testing. And in this case, we have 37 samples not correctly detected, but the rest are fine. That's why we're getting 79. You can try different technique. Let's try, for example, naive Bayes. We're getting something like 76. Let's try support vector machine, for instance. Of course, anytime you can click on the white area here and you can adjust the parameters. For support vector machine, there are two important parameters such as the kernel and the value of C. We're going to talk about that in the future. This is the first, practical session, and we don't want to, have some advanced topics. So this is just related to the first challenge we had, how to detect whether the car is actually had a crash or not. And we were successful to do this. Support vector machine here got us 100% accurate when we split the data into 70 and 30. So it's a good model here, and it could be used, it could be deployed. So whenever there is a new claim, you can always use this model and you can get a right result, or you can detect whether this car is actually been in accident before or not, and how much is the insurance claim that could be appropriate for that situation. Thank you very much, and I'll see you in the next video.